Hello, Professor. My name is Sreehari Kumar, and today I'm going to present my project 2 on social media app security assessment. The main goal of this project is to identify risks in social media applications, test them using a security tool, and highlight the findings. So I used the tool called MobSF, Mobile Security Framework. It's an automated mobile app security testing tool that lets us scan APKs for vulnerabilities. So in this demo, as you can see, I am using my Kali VM, and this is my IP. I'm also using I'm also using Docker because it allows me to run MobSF in a clean, isolated environment so that I can avoid setup errors and easily test it in a consistent environment. Also, you can see I'm using the sudo docker run command. So this command helps me to pull the official MobSF image and helps me to run it in the temporary container on port 8000. So that means like if I run this command, I should be getting this website, which is MobSF dashboard. Since I already logged in once, that is why it is not asking me to enter the credentials. And about the APKs, I'm using two APKs here. This is the first one, the Tusky. It is an open source Mastodon client from GitHub. I downloaded this version, and the second one is PixelDroid. It is a federated photo sharing app similar to Instagram, downloaded from the F-Droid. I think these two both are official websites, and it is safe to play with it. I can show I downloaded it in downloads and I renamed it to Tusky V29 and PixelDroid in order for me to understand them easily. So let's jump into our project. This is what we get. So what I do is like upload each of these files into this MobSF dashboard. And when I did, what I did first is Tusky V29 APK. So as you can see, this is the uh, basic dashboard which MobSF gives us in return. So this report provides key details such as app name, full name of the app, size, and main activity and stuff. This is a brief description, and it also includes Play Store information like the title of the provider, how many installs have their developer name, so everything, and even description. The dashboard highlights initial analysis results showing the number of exported activities, exported services, receivers, and providers. So this overview helps identify the app's attack surface by pointing out components that are accessible externally, and may require further security review. So let's next check permissions. As you can see, these are the permissions requested by Tusky APK. It included both normal and dangerous APK, dangerous ones, and the dangerous permissions can pose privacy and security risk if misused, such as exposing sensitive data, allowing file system access, or etc. Remember, this is an Android. I mean, this is a social media platform we are talking about. And next one we can show is the URL, which is right here. So the static analysis identified several hard-coded URLs and data handlers within the Tusk APK. We can see even a library conscript.jni.so. So these references appear in multiple libraries, including that. And these are hard-coded URLs which can potentially expose the app to data leakage or insecure communication. So this is a brief of these are the stuff we will get when we upload our APK into the MobSF. This is the binary analysis. So in binary analysis, it shows the app shades library implements strong security protection. So the binaries do not use rpath or runpath, which is acceptable, but means no custom library paths are set. Overall, the presence of modern mitigations indicates the app's compiled libraries are built with good security patches. So
So
in
in
order
order
to
to
like
like
summarize,
summarize,
The Tusky APK shows a moderate security posture like strong binary level protection, medium risk firm permissions, and all. This analysis highlight that while the app is generally safe and built with modern security practices, there are still areas that developers should tighten, especially regarding permissions and component exposure. So this is our Tusky result. Now let's go to the other one, which is PixelDroid. Similarly, we'll be uploading PixelDroid into MobSF just like this. Yep, and this is the uh, dashboard we will get. Similar to Tusky, we can see PixelDroid also has brief descriptions like the file name and size and all. It also includes export activity services, receivers, and exporter providers. Okay, so mm, let's check the permissions once. See, there are some more, I mean, compared to our Tusky, we can see comparatively more dangerous files here. And one among it is camera, which means, I mean, I have already mentioned PixelDroid is similar to Android, which uses, I mean, sorry, not Android, similar to Instagram. So this uses camera features from customers or the users. So it is status as state danger. This analysis shows that PixelDroid requires several permissions, some of which are categorized as dangerous because they can impact user privacy and security if misused. Now let's check binary analysis. If Yep, it's right here. No, the binary analysis of Pixel shows no shared object libraries found, no issues reported in BNF, and file analysis show no suspicious binary. Overall, that means the binary analysis suggests the PixelDroid relies primarily on Java or Kotlin code instead of native binaries. Instead of I mean, hard coding the codes or the important stuffs into the code, they are using these native binaries, which is reduces the risk of memory-based attacks. Let's check. Let's go through all of these. So that is the main usage of using this tool called MobSF. We can find hidden stuff like this. As in, the assessment reinforces the importance of integrating security testing into the app development life cycle. What I want to summarize is the result shows the open source social media applications share common weaknesses found in larger commercial apps. While both Tusky and Pixel Droid implement basic protection, they still expose users to risk through over-permissioning, insufficient hardening, and lack of strong network security practices. Addressing these issues using OWASP and ASBS guidelines would significantly improve their posture. That is my project, and thank you so much for your time.